All right, you guys, so the purpose of this lesson is to practice our vector word problems, okay? So you will need a calculator for this. Preferably you would have a ruler for this. Okay, so we're going to do two problems that are pretty similar. You have a choice, of course, to watch me step through both of them or to watch me step through the first one and then kind of try to do the second one on your own, okay? All right, so I know because I did this problem before that this problem has a lot of east, so I'm going to put my axis over here. Okay, you can read the problem before you start to kind of figure out the directions. This one has a lot of east and a lot of south, so I'm going to draw my axis kind of like that, okay? All right, so it says without wind, an airplane travels 200 miles per hour at a direction of 320. So of course this would be 360. Okay, so 40 degrees less than that would be maybe here-ish. Okay, and 200 miles an hour, of course, is pretty far, but we don't want our picture to take up too much space and not have anywhere to work. So I'm gonna go ahead and draw it like that. Okay, and this is 200. That would be, of course, the magnitude, and this is 40 degrees from there to there, okay? All right, and then it says, so that's what happens if there's no wind. If there's a 60 mile per hour wind at a bearing of south 35 east, okay, remember you have to put that at the tip right here, okay? All right, so from the end of the plane, not from the origin, okay, you want to go south, and then you want to go 35 to the east, so that's maybe here-ish, okay? And that's 60 miles an hour, which is about a quarter of the length of the other one. Okay, drawing it to scale just kind of helps you in the end figure out if your drawing's right. Okay, so that's 60. And of course, this little guy right here is 35 degrees, just this angle right here, okay? All right, then what you always want to do is you want to go from the origin, you want to draw a nice straight line to the end, like this, okay? So this I'm going to call plane, this I'm going to call wind, and this one is plane plus the wind, okay? I'm going to go ahead and do that in a different color. Plane plus the wind is my orange one, okay? Let me move this 200 so it doesn't look like it's part of that orange one. So this one's 200. Okay. All right, so take a look at that drawing, make sure it makes sense to you. And now you're just gonna write a vector for each problem. So we're gonna start with the plane. Okay, remember, this is the formula. You need to know the magnitude and the direction, okay? Which we know both of course. Okay, so the magnitude of the plane is 200, and I gave you the direction for this one. It was 320. Okay, and the magnitude still 200, and the direction is, oops, sorry, sine 320. Jeez Louise. Okay, all right, so that's how you set up the plane, okay? And then this part you could just type into your calculator. So in your calculator, in degree mode, type in 200 cosine 320, and you get 153.209i, okay? And then you type in 200 sine 320, okay, into your calculator, and you get 128.558 negative, of course, okay? So that just means that the plane went east that far and south that far. Okay, that's without wind. Okay, the wind's obviously going to pull it more east and more south. Okay, so now you want to do a wind one. Okay, the wind, again, I gave you the magnitude was 60. I didn't give you the direction, so be really careful on this. Okay, the direction is from the positive x-axis all the way around until you get to here. So of course this is 270 to here, but then the vector's another 35. So 270 plus 35 means it has a direction of 305. So 305. Okay, so just be really careful of that, okay? All right, and then again, this is just a calculator part. 60 cosine 305 is 34.415i, and 60 sine 305 is negative 49.149j. Okay, Now that we have both of those, this part's pretty nice. You just simply add the i's and j's. So you add the i's to the i's. Okay, 153 plus 34, okay, and you get 187.624, okay. All right, same thing, just add your j's. They're both negative, so it's going to be a bigger negative number. It's going to be negative 177.707. Okay, I got that by adding this to this. Okay, so this represents the components of my orange one, okay? So what I'm going to do is I'm going to draw a giant right triangle that has my orange vector as the hypotenuse, okay, like this, okay? And now that I have my vector, this tells me the components. So I know that 187 is this, how far that is, okay? And here, let me do that in a brighter color so you can see it. 187.624. Right here's the I part. And then this is negative 177.707 is the J part. Okay, so drawing a really good picture is pretty important in these problems. Okay. All right, so first thing when it says find the new speed, that's just magnitude. Okay, it's just the Pythagorean theorem. So you're gonna square both sides. Okay, and then you would obviously square root that. Be careful with that negative, put it in parentheses or just ditch it all together. Okay, so you would type that into your calculator and you can tell by the picture that it should be longer. So you should get something faster than what the plane was going before. I have 258.423 miles per hour. So that wind is really helping this plane out, okay? It was only going 200 miles per hour before. Now it's going almost 60 miles per hour faster, okay? Okay, so that's the plane. And then it asked for the bearing. Okay, so let's just talk about what the bearing is first of all. Okay, so the bearing is you start at the origin, and of course you have to go south for this one, and then you have to go east. So this is what we're looking for right there, okay? I'm going to use tangent to find this one, which of course would be the complement of the bearing, okay? So I'm going to do the tangent of my angle equals negative 177.707 over 187.624, okay? Type tan inverse into my calculator, and it gives me negative 43.445. Okay, so that's this angle right here, all the way to here is negative 43.445. All I have to do to get the bearing is to find the complement of that. So I just have to add 90, okay? And I will get 46.555, okay? And then don't forget to add those directions. So you have to go south, 46.555 in the east direction. Okay, all right, I know there's a lot of steps, okay? So we're gonna do another problem. It's pretty similar, so you can pause this, try to do the whole problem, fast forward to the end to see if you got the right answer, or if you want, you can just watch me step through another one, okay? All right, so I'm gonna move this up. Okay, all right, so this problem is about a boat, and the boat's going north 70 west, and then it says, and a speed. Yeah, a boat has a bearing and a speed, sorry, of 20 miles per hour. And then there's a current, and of course the current is going to throw the boat off course, okay? This problem is the opposite of the other one. It has a lot of north and it has a lot of west. So when you draw your picture, make sure you save room for that. I'm gonna go over here and draw me an axis like this. Okay, so the boat has a bearing of north 70 west. 70 degrees is a pretty big angle. I think it's probably like here. Okay, so this would be 70 right here, and this would be my 20. Okay, and then it says, and that has a speed of 20, so that's my magnitude, okay? And then it says the current has a bearing of north 55 east, okay? Don't forget you have to do that from the tip right here, okay? So north, and then 55 east, okay? That would be like here, maybe, okay? Or this is 55 right there, okay? All right, and that's only 5 miles an hour. It's kind of not too fast. Okay, and then again, I'm gonna use the same color. What you wanna do is you wanna start at the origin, okay? And you wanna go to the tip. see if I can do this with my fat pen. Okay. And that orange line represents where the boat will actually go because of the current's effect on that boat. Okay. So this is the boat, this is the current, and this is the boat plus the current. Okay. All right. So then that part is, you know, kind of the important, tricky part. Now you're just doing, you know, calculations. So the boat has a speed of 20. Okay, and we do have to find the direction for that, so be careful. The direction is obviously not 70 because you have to start here. You have to go 90 and then another 70 more. Okay, so that would add up to 160. So the boat has a direction of 160. So just be careful about that part. Okay, and then type these into your calculator and you get negative 18.794 and 6.840. Okay, all right, and then your current is only going 5. Okay, and again, I did not give you the direction for that one either. Direction is from here, this. Okay, so that is the complement of 55, which would be 35. So this is 35. Okay, type that into your calculator and you get 4.096 plus 2.868. Okay, and then when you do boat plus the current, just add the i's at the j's. So when I add my two i's together, negative 18 plus 4, I get negative 14.698. And when I add my j's together, I get 9.708. Okay, so check that out, make sure it's right. Go back and look at your work if something happened, okay? So then this is when I draw my triangle. Remember, the hypotenuse is always the vector b plus c, okay? Now I know the legs of my right triangle, okay? I know that the I component is negative 14.698, and I know the j component is 9.708. Okay, so now to find the speed, I can just use Pythagorean theorem. Okay, so I have negative 14.698 squared plus 9.708 squared. All that can be done in your calculator. Okay, and you get the new speed is 17.615 miles per hour. Okay, so in this case, the current is actually slowing the boat down because it's going the opposite direction. If one's going west and one's going east, that's going to slow that thing down, okay? Not too bad, just a couple miles per hour. Okay, and then it says it wants the direction, okay? So the direction measures from the positive x-axis. I know it's kind of confusing because I have another one right there, but let me see, do I have another color? Yeah, green. Okay, so the direction would be from here, okay, until I get to that orange line. So I need to know that, okay. There was 160 all the way to here. It's not going to be 160 anymore, okay. So what you can do is you can't actually find that because it's not in a triangle, but you can find this one. Okay, and those two are supplements, okay? So what we're going to do is we are going to find this green one. So tangent theta equals 9.708 over negative 14.698. Okay, and we're going to find that theta is negative 33.445. Okay, of course, it's negative because we use the negative, right? So that would be, remember, for that whole unit we did on this would be this one. Okay, so you just have to add 180 and you can get what you want. So just make sure the angle you get matches the quadrant. So this is a quadrant 4. We know ours is in quadrant 2, so you just simply have to add 180 to that. So the direction is 146.555. All right, you guys, so try your homework, email me if you have questions. You can also come to my office hours on Friday or stay in our Zoom class, and I can help you then too. Okay,